Hey guys, today we're solving number 1296 from LeetCode, divide array in sets of k consecutive numbers. So the title is really self-explanatory, and also the question is the same as 846. So we're given an array of numbers and a parameter k, integer, and we need to tell if it is possible to divide the array into subarrays or at least subsequences with only consecutive numbers of length k. So in this example, k is 4, and so we need to divide the array in subsequences of length 4 with only consecutive numbers. So unfortunately, I wasn't able to come up with the optimal solution for this problem. I was only able to come up with the O of n log n solution, but it is actually possible to solve this problem in O of n, where n is the length of the array. So here I've picked a O of n solution from the Discuss tab, and I've modified it a bit. And now I'm going to explain to you how it works. So the first thing we do is we check if the numbers array length is divisible by k, and if it is not, we return false, because obviously we can't divide the array into subsequences of length k if the array's length is not divisible by k. So then what we do is the classic algorithm to count the frequencies of the numbers in the array. So we start with an empty map, and then we do the very typical algorithm to store the frequencies of the numbers in this counts map. And then here we define our potential roots. So we define a root as the possible potential starting number of a sequence. So we know that a sequence can only start from a number that has no previous number, because if there was a sequence starting from a number that has a previous number in the nums array, then it would essentially remain as a leftover in the array, and we wouldn't then be able to divide the subarray anymore. So this needs to be the condition that tells us if a number is going to be a root of a sequence or not, is if there is a previous number in the array. So we just loop through all of the numbers and we say, okay, if the frequency, if the count of the number before the current number is 0 or it's undefined, then we push our current number to the roots. So roots is going to keep track of the current roots that we believe will generate the sequences, the consecutive sequences. So now what we do is we go through all of our roots, and every time we pop one from the end of the array. And if there is no longer any number in the array with that value, then we continue. We go to the next root. If there is any, if there is none, we can just return true, because we can be sure that we've visited all of the roots and we've consumed all of the numbers. Then we visit every number in this range. So we start from R and we end at R plus K. So for example, here you can see that here we start at 1 and we're going to need 4 numbers, so we're going to go up to 5, but we're not going to do anything at 5 other than checking if 5 has become a new root or not, because maybe we've consumed the last occurrence of 4 in the array, so 5 could become a possible new root. So that's exactly what we do here. We loop through all of the numbers up to R plus K and we consume them unless there is no longer any number with that value in our number, so the frequency is 0. In that case, we return false, because we can't build the sequence, so we need to return false. But the last iteration, we also check. You see, this thing about the building of the sequence, we only do that until we are less than R plus K. But this part is executed even if we are equal to R plus K. So for example, if we were the number 5 here, then we still need to do this part. We need to check if, in this case, that would be 5, if 5 has become a new root. And if it has, push it in the roots array. And if we never go onto this line, then it means that we have consumed all of the numbers in the array, we've consumed all of the roots, so we can safely return true. And as you can see, it gets accepted. So that's it for now, and bye.